Hey guys, this is Benjamin, who I've been spending time with the last couple days. Super red face right now, but he's precious. So I wanted to not let you just have a day off, so I'm going to show you some new stuff. Got it? Okay. Your substitute gave you 2 worksheets today. Hopefully one of them is called Are You Able with the Table? And one of them is called Money, Money, Money. Just wanted to take you through some of this stuff real quick. Okay. First of all, in basic form for an exponential function is f of x equals a times b to the x power. Okay. This is problem number 1 on that worksheet. So what it's trying to get you to realize is what effects do A and B have on the tables? Not necessarily on the numbers, but on the tables right here. Okay. So let's use a calculator to evaluate each one of these. So I'm going to use my iPad because it's what I have, and I don't have my calculator with me. Okay. So not there. There. So on your calculator, I'm going to start a new graph, and I want this graph to be 3 times 2. Oh dang, where is it? I can never remember where it is. Ah, there it is. Raised to the x power. Okay. See how it looks? 3 times 2 raised to the x power. I'm going to hit enter. It's going to give me a graph, and whoops, I have to use a little bit different keystrokes to get to my table, but you can get to your table. We can copy down our values. I need to go up just one. When x is 0, y is 3. When x is 1, y is 6. When x is 2, y is 12. When x is 3, y is 24. And when x is 4, y is 48. Okay? So I have these values put into my table. Now, knowing that the general form is a times b to the x power, hopefully you can look at this equation and know that a is 3 and b is 2. B is the one that's being raised to the power. Okay? So what happens if it's something like just 2 to the x power? If this 3 wasn't here at all, hopefully you'll realize that a in that case would be 1, and that's allowed, and that's okay. Okay? So what we need to do is figure out the common ratio in this table right here. When you're finding the common ratio, you take the y value and divide it by the previous y value. So if we're saying 48 divided by 24, that's a 2. 24 divided by 12, that's a 2. Another way, that's going up the table. Another way to think about it is go down the table. How do we get from 3 to 6? Well, we multiply by 2. How do we get from 6 to 12? We multiply by 2. Okay? Now, this has a common ratio. What does that common ratio happen to be? Well, I hope you see that that common ratio is b. All right? What I also want you to notice is that when x equals 0, look what that value is. Look what y is. Y is a. Okay? That's when x equals 0. So there's several other questions on the front of that page. One being, where does the a show up in the table? Hopefully you realize or remember, because I just told you that that is when x equals 0. And then it asks, where is the b value? Where does the b value show up? And hopefully you realize that that is where, that's the common ratio. Okay? So on the top of the next page, there's some notes. It says notes for functions in the form of f of x equals a times b to the x power. Okay? When this is true, sorry, I'm trying to get to my notes real quick. There we go. A, we're going to call a the initial amount. Initial amount or starting amount. Okay? And in the table it's when x equals 0. Okay? Hopefully you also realize that if that's where, when x equals 0, what is that point called on the table? That's called the y-intercept. Okay? B is what? Well, B is the ratio, the common ratio, not ratio, between consecutive terms in the table. But I think we can get away with just saying the ratio in the table. Okay? Now, y values will increase when B is greater than 1. Okay? That's when y values will increase. So when will y values decrease? Y values will decrease when the value of B is between 0 and 1. Okay? You have some other tables to fill out on that paper. Go ahead and get those done. I'll check those when I get back tomorrow. Answer the questions that are all there. The other page that you have is a page called Money, Money, Money. Okay? And it talks about, has a table like this at the top, first of all, but it talks about a college loan. Okay? If we borrowed $20,000 for college to help with tuition, room, and board, you don't have to make any payments until you leave school. However, you're still going to pay interest at the rate of 12% annually. Okay? So first thing we need to do is fill in the table. At this point, we don't have any sort of equation to substitute in. So we're just going to, oops, not that. We're just going to look at the calculator. Okay? If we start with $20,000, we multiply it by 12%, so 0.12, the value that we get is $2,400. Okay? Now, that's not the amount that we owe because that's just the interest. So to figure out how much we owe, we actually have to add the initial $20,000 to get $22,400. Now, those of you who were with me in Algebra 1, I know we talked about this. The rest of you, I hope you can catch on. Otherwise, the rest of you help them out, please. We can actually take $20,000 and multiply it not just by 0.12, not just by 0.12, but 1.12. Oh, yikes. 1.12. The 1 here takes into account the original amount, and the 0.12 is the interest that you're adding on. So when you multiply it by 1, you're essentially adding this other 20,000 like you were in the beginning. It's just a one-step problem instead of a two-step problem. Okay? So our first amount is 22,400. Okay? And so using the laws of the calculator, if I just hit times, it's going to pull my previous answer up because I still need 12% of that. And that's going to be 25,088. Okay? 25,088, and so on. Well, hopefully in this way that I'm showing you, in this way that I'm showing you right now, you can see the actual function that we need to use to be able to calculate any number of years after you graduate. And that would be what we initially started with, which was the $20,000. So in this case, that would be A, what we just learned, times the 1.12, the initial amount plus the 12% raised to the x power. And that's going to be your equation for this formula. Okay? The 1.12 works when we are gaining value. We're gaining 12%, or the interest is accruing 12% a year. Now, what happens like on part B, the car value, that depreciates in value. In this problem, we could add the 12% to 1 because it's earning interest, stuff is being added. When it's depreciating in value, that money is being taken away, and so we would actually subtract whatever percentage is in the second part from 1. So just keep that in mind when you do that. Again, that's something we can talk about tomorrow if you need to do that. I do hope to be back tomorrow. I went to catch my plane at 10:35 this morning. I got there about 9, and they were like, go away, read some books. because the weather in Dallas was too bad, which was weird because I talked to Coach Rob and she was in Arlington and she's like, it's not bad at all. I'm like, okay, well, I don't know, they won't let us on the plane, so I guess I'll just wait. So I will try to get back and see you guys tomorrow. I am booked on a flight. So again, I hope I see you on Tuesday. Please behave for our wonderful sub who's with us today. And again, I'll see you tomorrow.